Variables is quantity that may change without that context of mathematical problems or experiment. So, ibig sabihin po, the letter X, Y, and Z are common generic simple using the variables, also called a data, items, defined as the alphabetical character that express my numerical value or a number.
So they already discussed the definition of variables. I will just give additional definition and example of variables. X, Y, and Z are the example of variables wherein used in algebraic expressions and equations. In other words, variables are symbols for a number where the value is not known. For example, x positive 5 is equal to 10. So x is the variable.
Part of equation. The equation in mathematics are formed of different parts. They are variable, constant, coefficient, operator, and term. Variable is an entity can take on different values. Constant, not dependent on some variable, not changing as that variable change. Coefficient is a numerical or constant quantity placed before and multiplying the variable in an algebraic expression. Operator, any symbol that indicates an operation to be performed. Term can be a constant or variable or both in an expression.
The variable can be classified into the two categories, namely independent variable, a variable often donated by who variation does not depend on that of others. Is a variable that does not depend on any others variable in values. Dependent variable, a mathematical variable whose value is determined by the one of the more variable in a function. For example, you want to compare brand of the paper towel to see which hold the most liquid. Independent variable in your experiment will be the brand of paper towel. The dependent variable will be the amount of the liquid absorbed by the paper towel. In an experiment to determine how far people can see into the infrared part of the spectrum, the wavelength of the light is the independent variable. That weather of the light is observed by response in the dependent variable. If you want to know whether caffeine effect in your appetite, the presence, absence of the given amount of the caffeine will be the independent variable. How angry you are will be the independent variable.
So, I just add another information about independent variables and dependent variables and dependent variables. So, dependent variables is the one who can change in an experience, while independent variables are the result of the independent variables.
Independent variables cause dependent variables effect.
In independent variables, there is a cause. For example, does someone age? So, the effect of dependent variables in independent variables is every year the age of each person increases.
I will discuss about the language of set. So what is set? A set can be viewed initiatively as a collection of objects. Meaning to say, set is the way of collecting or groupings of an object. And the objects that belong in a set are we called elements. Elements or the member of the set. And take note, when we are writing the name of the set, we must always use capital letters. These notations means X is an element of S. So, how do we read these symbols? We can read this like X is an element of S. So, as you can see, the name of our set can be written in a capital letters. And next notation, in this notation, means that X is not an element of S. So these symbols means that is not an element of S. And also, how do we read these symbols? We can read this as X is not an element of S. A set can be specified using the set roster notation. Examples, let A is equals to 1, 3, 5. Set B is equals to 5, 1, 3, and set C is equals to 1, 1, 5, 3, 5, 3, 3. What are the elements A, B, and C? How are A, B, and C related? As you can see, A, B, and C have exactly the same three elements. It is 1, 3, 5. Therefore, A, B, and C are simply represented in different ways. Next, is 0 enclosed with the braces is equal to 0? No, they are not equal because this set is represented as a set with one element. What is her element? It is 0. And while this one is represented the number of elements. And again, for each non-negative integer n, let us use u sub n is equals to n is comma negative n, and find u sub 1, u sub 2, and u sub 0. All you have to do is to substitute the values to the n. Another way to specify a set uses what is called the set builder notation, the set of elements x and s, such that Px is true.
Set theory. Set theory is a mathematical theory that developed to explain collection of objects. Basically, the definition states that it's a collection of elements. These elements could be numbers, alphabets, variables, and etc.
Symbol number 1 stands for set, meaning a collection of elements. Example, 1 element, 2 element, 3 element, and 4 element. Symbol number 2 stands for union, meaning in A or B or both. Example, subset union equals 1 element, 2 element, 3 element, 4 element, and 5 element. Symbol number 3 stands for intersection, meaning in both A and B. Example, subset intersection equals 3 element and 4 element. Symbol number 4 stands for subset, meaning every element of A is in B. Example, 3 element, 4 element, and 5 element subset.
Universal set symbol. A universal set is usually denoted by capital letter U. Also sometimes it is denoted by epsilon. It is a set that contains all the elements of other sets including its own elements. U equals counting numbers. U equals set of integers. Complements of set. If A is a set, then complement of set A will contain all the elements in the given universal set U that are not in the set A. It is usually denoted by A or AC. A is equal to elements of the universal set. Denote not an element of complements of sets. Set boulder notation. The example of notation of set in a set boulder form are if A is the set or real numbers, A is equal XC, XER. X belong to all real numbers. If A is a set of natural numbers, A equals XC, X greater than 0.
Certain set of numbers are so frequently referred to that they are given special symbolic names. R is the set of all numbers. Z is the set of integers. Q is the set of all rational numbers. The real number line is called continuous because it is imagined to have no holes. Because the integers are all separated from each other, the set of integers is called discrete. The name discrete mathematics comes from the distinction between continuous and discrete mathematical objects.
What is a relation? A relation is a collection of ordered pairs containing one object from each set. If the object X is from the first set and the object Y is from the second set, the objects are said to be related if the ordered pair X and Y is in the relation. A function is a type of relation. Example, negative 2 and 1, 4 and 3, 7 and negative 3. Usually, written set notation with curly bracket.
Types of relations. Empty relation is one in which there is no relation between any elements of a set. For example, if a set A equals the set of 1, 2, 3, then one set of relations can be R equals the set of X and Y, where 1X minus Y1 equals 8. Universal relation. A universal or full relation is a type of relation in which every element of a set is related to each other. Identity relation. In an identity relation, every element of a set is related to itself only. For example, in the set A equals the set of A, B, and C, the identity relation will 1 equals the set of A and A, the set of B and B, the set of C and C. For identity, inverse relation is seen when a set has elements which are inverse pairs of another set. Reflexive relation. In a reflexive relation, every element maps to itself. An example of a reflexive relation is the relation is equal to on the set of real numbers, since every real number is equal to itself. Symmetric relation. In a symmetric relation, if A equals B is equals A is also true. In other words, a relation R is symmetric only in open parenthesis B and A close parenthesis. ER is true when open parenthesis A and B close parenthesis ER. Transitive relation. A transitive if for all elements A, B, C, and X, whenever R relates A to B and B to C, then R also relates A to C. Each partial order as well as each equivalence relation needs to be transitive. So, what is a function? An expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable, is a relation for which is value from the set, the first components of the ordered pair, is associated with exactly one value from the set of second components of the ordered pairs. Functions are ubiquitous in mathematics and are essential for formulating physical relationships in the science. If a variable y is so related to a variable x that whenever a numerical value is assigned to x, there is a rule according to which a unique value of y is determined, then y is said to be a function of the independent variable
This is the two types of function. One-to-one function. A function f a to b is said to be one-to-one function if no two distinct elements of A have the same image in B. Onto function. A function f, a function f from a to b is called onto if for all b and b there is an a, if a is equal b.
Discussions about the relations and function. Relations and function are the most important topics in algebra. Relations and functions, these are the two different words having different meanings mathematically. An ordered pair is represented as input and output. Relations is a set of coordinates written by x and y, while the function is a specific type of relations, is a set of ordered pairs x and y, where each x coordinate is matched with only one coordinate. In mathematics, a function can be defined as a rule that relates every element in one set, called the domain, to exactly one element in another set, called the range. For example, y equals x plus 3 and y equals x squared negative 1 are functions, because every x value produces a different y value. The relation shows the relationship between input and output, whereas a function is a relation which derives one output for each given input. Note, all functions are relations, but not all relations are functions.
오늘도 빨간 버스를 타요. 난 경기도에 살아요. 늘 금방 갈 수 있다 말하지.